Tensors are most easily understood by discussing the progression of tensor ranks. Generally, when one talks about tensors, though, one is referring to tensors of rank 2 or higher. So we're looking at these 3D tensor cubes. A scalar quantity is simply a number, as we know. It only has magnitude. It can be designated as a tensor rank of 0, which would be like temperature. A vector quantity has magnitude and direction in two-dimensional space. So when we talk about a vector, it's a 1D tensor. And that's what we see there. For example, if it has x and y components in a three-dimensional space, then it has 3 components. Vectors can have any number of dimensions. But if we're talking about a 2D tensor, this is where we're going to see a matrix being made. Now, if we want to get to a 3D tensor, and or a tensor cube, if you will, it's what we see here. And what that is where we stack these matrices on top of each other. And what we get is a cube. If we take these cubes and stack them on top of each other, we get what's called a 4D tensor, or a vector of cubes. And then lastly, if we take these 4D tensors and line them up into a matrix, we get a 5D tensor matrix of cubes, where you could get all kinds of scalar information that we can turn into vector information. So examples of scalars, again, are temperature, is something like that, a number that does not have a direction. Vectors, as we know, an example of that would be an electric field. So where a test charge is placed at a point in space, we'll move at a certain speed and direction as represented by the vector at that point. And then lastly, what's a tensor field? A tensor field has a tensor corresponding to each point in space. An example is the stress on a material, such as the construction beam in a bridge. Other examples of tensors include the strain tensor, the conductivity tensor, and the inertia tensor. So tensors are something that we will use.